Let's take a look at how to predict the products of a precipitation reaction and then balance a precipitation reaction. So the one I'm going to work out is lead nitrate, lead 2 nitrate, PbNO32. And we know that that's aqueous. I'll leave that out for right now, but it has to be aqueous because when we mix these two things together, these two solutions together, we're looking to see whether a solid forms. The other reactant is potassium iodide, Ki. Now, in our notes it says the first thing to do is to just write down the reactants with their correct molecular formulas. And obviously that's an important part. If you don't have the right formula, this isn't going to work out very well. Step 2 says identify the cations and anions and their charges. And what that means is it says, okay, well let's look at, now Ki, that might be an easier one to start with. We know that K is a +1 and that iodide is a -1, so that's a useful thing to know. And we know that now the nitrate one, lead 2 nitrate, is maybe a little trickier if you don't know the name of it. We know that the nitrate ion is NO3 with a negative. So what that means is that in order for this to work, if we did the crossover method, we might predict that lead is a +2, and since there's 2 nitrates at a -1, lead is a +2. Okay, so we've identified the cations and anions. Lead and potassium are the cations, nitrate and iodide are the anions. We've predicted their charges. Now what we're going to do is we're going to switch them. So let's see if I can color code this correctly. The Pb2 plus, that is going to pair up. Now positive is going to pair up with the other negative, and so the I minus is going to pair up with that. And then the K plus, that's going to pair up with the nitrate. And so K plus, whoops, let me go back here, switch colors, is going to pair up with the nitrate. Now, I heard somebody say that this is sort of like switching partners at a dance, that, okay, lead was paired up with nitrate, it then sees the iodide, and so lead pairs up with the iodide, the potassium pairs up with the nitrate. So that's one way to think of it. Now, so that's step 3. Step 4 says, okay, you've got these ions paired up now. Let's put them together to make neutral compounds. And that's where you sort of go backwards now and say, okay, well, if lead is a 2+, how many iodides do you need? Well, we could do that crossover method again, where we take the charges. And what we would find is that the product we would predict would be PbI2, lead 2 iodide. And our other product, when we did the crossover, well, I guess we don't need to do the crossover here because K plus and NO3 minus, both of those have opposite but equal charges, and so we projected the product would be KNO3. Now, the last, next thing to do is we need to balance this chemical equation. And so that's just sort of going and looking and saying, okay, well, one thing, there's one lead. On the reactant side, there's 2 nitrates in the formula, so we might need a 2 out in front of that. That changes the fact that we have 2 Ks, and we have 2 iodines, so that must mean that we need 2 Ki there. Now, the final question that we need to ask ourselves is whether these, how do we even know the reaction is going to occur? Because we want to see a solid form. If we don't see a solid form, then nothing's going to happen. And so what we need to do is we need to look at each of these things. And for example, what we know, let me go back up to my rules and make sure I'm telling you the right rules. If you're looking at a different book, you might see a different set of numbers for these, so just realize that this is referring to our things. In the notes it says Rule 1 says that Rule 2 actually says that all nitrates NO3 minus are soluble. It doesn't matter what nitrate is paired up with. And so what that might indicate is that, okay, these two, this is AQ, and that makes sense because that had to be aqueous to begin with, but it also indicates that this over here is AQ. this is not the solid that we're seeing. This is going to be dissolved in the water. So the question then is, well, what must be the solid, or are we even going to see a solid? Well, Rule 3 in our notes says that most salts, most things that have iodide in them, most ionic compounds are soluble, except for a very few specific ones. And always check to make sure the exceptions. It says AgX, that means it could be Ag paired up with iodine, silver paired up with iodine, mercury paired up with iodine, or lead paired up with iodine. So PbI2 is insoluble. It's an exception to the rule. And so the Ki is aqueous, but the lead-2 iodide is a solid. And so what this would indicate is that this right here, this lead-2 iodide, that's the yellow solid that we would see form. And there was a video that showed that. And so that's what we'd be looking for. And so we would say, most definitely, yes, a reaction occurs. And so that's how you would balance a precipitation reaction. So this one does involve a lot of thought processes, and it requires you to know the charges in your ions. So that's how you do that.